Okay, solving a distance, rate, and time problem using a linear equation. Two trains leave stations 228 miles apart at the same time and travel toward each other. One train travels at 90 miles per hour while the other travels at 100 miles per hour. How long will it take for the two trains to meet? So what you want to do for a distance, rate, and time problem is you always want to set up the same table. So the table is going to look something like this. Rate times time equals distance. But I always put an extra little column to the left, and I'll explain that in a minute. I make two rows because there are two situations. We have two trains, so I'm going to call this one train 1 and this one train 2. Okay, and then I just start at the beginning of the paragraph and just start filling in my table. Two trains leave stations 228 miles apart. Okay, so the distance is the same, 228, so I can write that kind of across both of them because it's the same. At the same time, so the time is going to be the same, but we don't know what it is, so we'll call that X. One train, so train 1, travels at 90 miles per hour, that's the rate, while the other travels at 100 miles per hour. That's the rate of train 2, 100. How long will it take for the two trains to meet? Well, since rate times time equals distance, and I know the distance is 228, I'm going to have something equaling 228 because that's the distance. So what that something is you have to multiply this together because it's rate times time. So 90 times x is 90x. And then you have another train, so you got to add that one to it. 100, sorry, this is a 0 here. 100 times x is 100x. And then you solve your equation. So 90 plus 100 is 190. We've got 190x equals 228. Divide both sides by 190. So x 1.2. And how long will it take for the two trains to meet? So if they're traveling miles per hour, so it's going to take 1.2 hours. And that one is finished. Okay, so on the next one, Joe drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 10 hours. When Joe drove home, there was no traffic, and the trip took only 7 hours. If his average rate was 18 miles per hour faster on the trip home, how far away did Joe live from the mountains? So again, rate times time equals distance. You're going to use this for every single one of them. You make your extra little column in 2 rows. Okay, so we have, he's going to the mountains and he's going back home. Okay, so Joe drove to the mountains last weekend. There was heavy traffic on the way there, and the trip took 10 hours. So to the mountains, the time was 10. When Joe drove home, there was no traffic, and the trip only took 7 hours. So going back home, it only took 7 hours. If his average rate was 18 miles per hour faster on the trip home, okay, so on the way back, he's going 18 miles an hour faster. That means we don't know how fast he was going on the way there. So we have to call that x. So we have the first rate is x, and on the way back he was 18 miles an hour faster. So that's x plus 18. So then, how far away does Joe live from the mountains? We don't know this part. So if it's a situation where they do not give you the distance, you have to set each one of these situations equal to each other. So 10 times x equals 7 times this whole thing, x plus 18. Then you solve that. 10x equals 7x And then 7 times 18 is 112. So plus 112. So I'm going to subtract 7x from both sides. Okay, 10 take away 7 is 3. 3x equals 112. Divide both sides by 3. So x equals 3 goes into 11 2 times. 3 goes into 11 2 times, that's 9 with 2 left over. 3 goes into 22 7 times with 1 left over. So 27 1/3. So you'll have to excuse me because yes, I do make mistakes sometimes, and I had a feeling that was one, and it is. 7 times 18 is actually 126. So I'm going to need to do this. I knew my answer was a little bit off, or it sounded strange. If you get fractions, you might want to double check your work. You can get fractions, it's a possibility. But it doesn't hurt to check your work anyway. So x equals 3 goes into 12 4 times, and 3 goes into 6 2 times. So x equals 42. But you've got to be careful on this. Remember how they didn't give you the distance? So you need to figure out what you just found. You found x. Well, we said that was the first rate. But rate times time equals distance. So to find the final answer, you have to actually do rate that you found times time equals distance. So it's 420 miles. That's the final answer on that one. Okay, the next one. Rate times time equals distance. You've got your extra little column. Okay, 2 cars. So we have car 1 and car 2. Leave town 1,000 kilometers. The distance is 1,000. Apart at the same time. Same means it's the same, but we don't know how long it was, so we'll call those x. And travel toward each other. One's car rate is 14 miles per hour more than the others. So if we call this x, the other one has to be x plus 14. Because it's 14 miles an hour more than the others. If they meet in 5 hours. So actually, they did give us the time. So we can replace that with a 5. What is the rate of the faster car? We'll talk about that in a minute, what they're asking you. But first of all, again, rate times time equals distance, and they give you the distance, so we put equals 1,000. Okay, the first car is 5 times x, which is 5x. And then the next car, 5 times x is 5x. And 5 times 14 is 70. Now, remember, this has to be multiplied by everything over here. So I did 5 times x and 5 times 14. So I get 10x plus 70 equals 1,000. I'm going to subtract 70 from both sides. So 10x equals 930. Divide, oops, sorry, didn't want to do it that way. Divide both sides by 10. X equals 93. But again, you have to look at what you just found. You just found x, which is the rate of the slower car, because the other one's adding 14 miles extra, miles per hour extra. And they want to know what's the rate of the faster car. So So you have to take your answer and add 14 to that, and you get 107 kilometers per hour.